Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the final problem from the Special Maths Contest 2025. Hooray! We've made it to the end. Okay. Don't forget to like, share, comment, and subscribe. And also, please stay tuned as we've announced the registration for the next edition of the Special Maths Contest is now open. Okay, let's dive into this question. It says, we say a summation of two positive integers is permutational if the digits of the result of the sum has digits which is the permutation of one of the summands. For an example, 45 plus 9 is equal to 54 is a permutational sum because 54 is a permutation of 45. How many permutational sums with summands less than 1000 are there that involve 27 as one of the summands? Okay, so let's look at uh, uh, the case where the both summands have one digit. Rather, one of the summands has one digit. So if we have something like A plus 27 equals to A. So we see that there's no possible permutational sum when one of the summands has one digit because the only permutation of A is A itself. Okay. So let's look at the case for two digits. So let's say we have AB. So there's only one way to permute AB, so that would be BA. Okay. So for two digits, we have AB plus 27 equals to BA. Okay. Another way we can have is AB plus 27. So if what is being permutated is the 27 itself, equals to 72. And we'll come to this. So for this first case, what do we have? We get that AB plus 27 equals to BA. We can expand this out. So this 10A plus B plus 27 equals to 10B plus A. Okay. And we have 27 equals to, so we have 10B minus B, that's 9B, A minus 10A minus 9A. Okay. So we have 3 equals to B minus A. So we divide through by 9. Okay. And there are how many possibilities for this? So recall that we don't want A to be 0. Okay. So A must not be 0. So A starts from 1. So we can have uh 4 minus 1 up to 9 minus 6. Okay. So this gives us 6 possibilities. Okay. And so this is the case where, so I'll just put it maybe somewhere here, this corner. So we have AB plus 27 being BA. So we have 6 possibilities. Okay. Now we have AB plus 27 equals 7. So there's only one possibility. So we just solve. So I will get that AB is equals to 45. Okay. So we have for two digits, we have 7 possibilities. Okay. So let's look at 3 digits, and this is where we begin to get a whole lot of cases. So uh, I'll look at, so first of all, I'll look at some cases that I will try and, just eliminate immediately. So let's say we have something like 27 plus ABC equals to, okay, so I'll list all the cases first of all. So we have 27 plus ABC equals to ACB. Okay. So recall that ABC, we have how many permutations? There are 6 permutations of ABC. So that will give us an idea of the cases. So it means there'll be 5 cases because uh ABC is fixed and you just have to find all the other possible permutations. Okay, so we have CAB, we have 27 plus ABC being equal to BAC. So we should have 5 cases. So all the permutations of ABC different from ABC. Yeah. We have CBA, and this should be the last case. So 27 plus ABC, and we have BCA. Okay, so I'm going to use a different color now. So for the first case, we just have these two swapping places. Okay, so we have 27 plus, so we just have uh so we have 27 plus ABC being equals to ACB. So when we simplify this, so when we have we can take out the A from both sides. This reduces to 27 plus BC equals to CB. Okay. Now, when we simplify it this way, so how I mean we can take the A from both sides. We can just bring out 100A, okay, and bring out 100A from here and cancel both sides. Cancel it from both sides. Okay, so this reduces to this, which then reduces to what we have in this box here, which we got to have six possibilities. But recall that in this scenario, A could not be zero, but here we can have that B can be zero. Okay, so what we'll have is now from 3 minus 0 to 9 minus 6. Okay, so seven possibilities. So seven possibilities for B and C. Okay. But then A can range from 1 to 9. Okay. So A cannot be 0. A can range from 1 to 9. So that will give us 9 times 7 possibilities. So this gives 9 times 7. So I just put 9 times 7 possibilities. Okay. And then I'll erase. So let me erase. So the first one, we get 9 times 7 possibilities. That's going to be 9 times 7 is what? Who can help me with this? Seems difficult. Oh, wait, I've gotten the answer. 9 times 7 is 63. Okay. Now let's look at the next one. So we have 27 plus this. So let's see what we can do. So we have 27. Let's expand this out. So 27 plus 100A plus 10B plus C equals to 100C plus 10A plus B. Okay. So this will simplify to 27 equals to, so 100 C minus C, that's going to be 99C plus, rather, this is going to be minus. So minus, so we have 10A minus 100A, that's going to be 90A. Okay. And then we have plus, so we have uh, B minus, okay, so it's going to be minus, B minus 10B, that's going to be minus 9B. And we can divide through by 9. So we have 3 equals to 11C minus 10A and minus 9, rather minus B. Okay. Now we can take mode 11 of both sides. So if you take mode 11 of both sides, we have 3 is congruent to. So we have this is going to be go to 0. So minus 10A mode 11 is going to be what? Minus 10 is what? Minus 10 is minus 1. Okay, so sorry, minus 10 is going to be 1 rather. So we can just put so minus 10 is congruent to 11 plus minus 10 mode 11. And so we have minus 10 is congruent to 1. Okay, so we can just put 1A. We don't have to write 1. So A minus B. Mode 11. Okay. So the good thing about this is that we can break this down. Okay, so to two possibilities. So recall that we're dealing with digits, so from 0 to 9. Okay, so there's a maximum difference. So the maximum difference is 9 minus 0, which is equals to 9. Okay. And there's a minimum difference, of course, which is just going to be 1. Okay, or it can be minus 9 in any case. But yeah. So what we have here basically is I'm more interested in the absolute difference. Okay, so there are two possibilities. So we either have A minus B. So if A is bigger than B, we have A minus B is equals to 3. Of course, because mode 11, right? Mode 11, we're talking of residues in when the numbers are divided by 11. So that's already, these numbers are already bigger than the possible values of 0 to 9. So that's why I can conclude straight to this equality. So we have either A minus B is equals to 3, or we have B minus A equals to, so when you take the negative of both sides. So let me just scroll down, or we can, so this is also equivalent to, so we can have 3 minus 11, that is minus 8, congruent to A minus B mod 11. Okay, and then we can multiply both sides by minus 1. So we have uh 8 equals to B minus A mod 11. So we have two possibilities. So it's either A minus B is equals to 3 or B minus A is equals to 8. Okay, so two possibilities. So now let's work on these two possibilities. Okay. So for B minus A being equals to 8, okay, so recall that A cannot be 0. Okay. So if B minus A is equals to 8, it means this that there's only one possible value. So that is going to be B will be 9 and A will be A will be 1. Okay. So only one possibility. So 9 minus 1 equals to 8. So B and A. Okay. So if 9 minus 1 is equals to 8, that leaves only one possibility for C. So we have this would be 1, 9, 2. So equals to 2, 1, 9. Okay. So that's the only possibility. Now, if we look at the other case, A minus B equals to 3. So let's look at A minus B equals to 3 and see what we can get from there. Okay, so let's erase this. So if you look at the case A minus B equals to 3. So if you plug if you plug A minus B equals to 3 into this equation here, what do we get? So let's say we have not this equation, rather, let's plug it into the simpler one. So we'll have 3 equals to 11C minus 10A. Okay, so remember B minus B is going to be what? 3 minus A. Okay, so plus 3 minus A. Okay, so 3 and 3 will cancel out. So we have 0 equals to what? 11 into C minus A. Okay, so I just skipped a step. So minus 10A minus A is minus 11A, and I can factor out 11. So we get C is equals to A. And if C is equals to A, okay, so if C is equals to A, that case reduces to, so 27 plus, so just pay close attention here. So if C is equals to A, we have A, B, A, C equals to A, B. Okay, so this reduces to the case where, uh, so this reduces to the case of 2 digits, which we've already accounted for. So it just reduces to BA, 27 plus BA equals to AB. Okay, so this reduces to the case where we have 2 digits and they're just being swapped, which has been counted for in this first case of 3 digits. So this now just becomes only one possibility. Okay, so one possibility. So I'll just circle it. So we have certain number of possibilities we have. So 7 possibilities. So we're adding up. Okay, so let me erase this. So let's go to the next case. I think I can erase all this. So let me erase all this. Okay. I don't want to scroll while I'm writing so that you can always, focus on the question, on the problem statement. Okay, almost done, almost there, almost there, almost there. And one here. Okay, so let's go to the next case. And so we have 27 plus, so 100A plus 10B plus C equals to 100B plus 10A plus C, okay? So C cancels out, so we just have 27 equals to, so this would be 100B minus 10B, that'll be 90B plus, uh, rather this will be minus, so minus, so we have 10A minus 10A minus 100A, that's going to be 90A. Okay, so we can divide through by 9. We have 3 is equals to 10 into B minus A. Okay, So basically, we have 10 does not divide 3. Okay, so this is not possible. So this is not a possibility. Okay, so we have 0. Okay, now let's look at, so let me erase this. So let's look at the next case. So we have, so this would be 100C plus 10B plus A. Okay, so I have 27 equals to, so 100C minus C, that would be 99C. Okay, 10B minus 10B cancel out, okay? Then A minus 100A, that would be minus 99A. Okay, so we can divide through by 9. So we have 3, can factor out 11. 3 equals to 11 into C minus A. So we have 11 does not divide 3. So this is not possible. So 0 possibilities for that one. And let's go to the final case. Okay. Stay with me. Stay with me. We're almost done. We'll be done soon. Okay. So we have this would be 100B plus 10C plus A. Okay. So we have 27 equals to, so 100B minus 10B, that'll be 90B. 10C minus C, that'll be plus 9C. A minus 100A, that'll be minus 99A. Okay, so we can divide through by 9. So we have 3 equals to 10B plus C minus 11A. Okay, so 10B plus C minus 11A. So just to confirm that I have that. Okay, so what can we get here? So once again, we can take mode 11. So we have 3. Okay, so 3, this is going to be equal to, so we have 10 is congruent minus 1 mode 11. So 3 is congruent minus B plus C. So 11 goes to 0, mode 11. Okay. And as before, the same argument. So what does this mean? We have C minus B equals to 3 or B minus C equals to 8. Okay, so these are the two possibilities. Okay. So if we have C minus B is being equal to 3, we set C minus B equals to 3. So if we plug that into this equation here, let me switch back to my red. So we'll have 3 equals to, so basically C is equals to B plus 3. Okay. So we have 10B plus B plus 3 minus 11A. So 3 cancels out. So this is equivalent to 0 equals to 11 into B minus A. Okay. So basically, I hope everything is okay. Let's see. Mhm. Okay. So we get, yeah, 11 equals to, so we basically get B equals to A. And if we have B equals to A, so let me just write it out down. We have B equals to A, that case becomes, so we have 27. Okay, so let me write, so to becomes 27 plus B equals to A, B equals to A. So we have AC equals to, so we have ACA. So as before, it reduces down to the case of 2 digits, which has already been accounted for in the first case for 3 digits. So it reduces down to just 27 plus AC equals to CA. Okay, so we can throw that away for now. So we then go straight to the case of um, B minus C equals 2. So basically, we cancel this out. So B minus C equals to 8. So we know that so in this case, we know that we can include 0. So we have B can be 9. So we can have 9 minus 1 equals to 8. We can have 8 minus 0 equals to 8. Okay. So if we set So there are two possibilities. Okay, so let me just scroll down a bit. Okay, yeah. So if we have nine and one, okay, so if we have 9 and 1 and we plug it into that equation, we have 3. So let me erase this. So if we plug in b equals 9, so this will be 90. C will be uh C will be 1. So 90 plus 1 minus 11a. So here we need so here we get that 11a should be equals to, so 91 minus 3, that is 88. So this implies that a should be 8. Okay. So it means one possibility is so when a is 8, okay. So when a is 8 and b is 9 and c is 1, and then the other possibility, so let's just do it. We plug in 8 for b. So that will be 80 plus, so c will be 0 minus 11a. Okay, so we have 11a equals 8 minus 3, that's 77. So we have a equals 7. So the other possibility is 780. Okay, so there are two possibilities here. Okay, so let's add this up. So when it was one digit, we got 0 possibilities. 2 digits, we got 7 possibilities. Okay. Then 3 digits, we have 63 plus 1 plus 2. Okay, so 7 plus 63 is 70 plus 1, 71 plus 2, 73. And that's option D. Okay, I hope you enjoyed this problem and I hope you enjoyed this series. And I hope you love the problem set from the SMC 2025, 2024 rather. Okay, so stay tuned. We'll still be publishing videos, from different contests that we propose. Maybe we'll look into SMC 2023. Who knows? But don't forget to like, share, comment, and subscribe. And see you in the next video. Goodbye, everyone. Cheers.